All right, so 10.6, scatter plots and trend lines. So we've got a few things we need to talk about, and bear with me, it's kind of all over the place, all right? So first thing is, what is a scatter plot? This is a graph that shows two sets of data. So what this sometimes is called is bivariate data, because there's two sets of data, so two variables. That's all that is. Um, so we're going to skip correlation for a second. I'm going to scroll it up here so we can talk about trend lines for a second. So a trend line is this definition up here. So we have line of best fit. A trend line is a straight line that comes as close as possible to points on a scatter plot. Okay, it's a line that we're going to draw in. So they are approximately the same number of points above and below that line, and we're going to ignore any outliers. Okay, so that's what a trend line is. It's also called line of best fit, so you'll see that phrase, that vocabulary more often, I feel like. And again, this is going to be a straight line that we draw that in. Okay, so we're going to scroll down a little ways so you can see some new stuff. So going down, and we'll come back up in a minute. So the first thing I want to talk about is correlation. Okay, correlation. It's also called association, and all this means is the relationship of the data. Okay, so you can show a positive relationship, you can show a negative relationship, and you could say no relationship. So if a relationship is positive, X is increasing, or as X increases, Y increases. So it just kind of means like you have that positive slope going on right here. So as X is increasing to the right, Y is also increasing up. So you've got this uphill slope right here, kind of like a positive slope. So for negative, same idea. You've got this data that's kind of going in that downward motion. As X is increasing, Y seems to be decreasing. So if you have a negative relationship, that's exactly what that is. So your X is going to increase, but your Y is going to decrease, just like when you have a negative slope. So if you have no relationship like we have here, there's no relationship between X and Y. There's no conformity of what this data is doing. You can't group it in a way to show positive or negative. So that's no relationship. Okay? So the next thing I want to talk about is what a cluster and outlier means. So for a cluster is a set of closely grouped data. So, like a group, a bunch. The data can cluster around a point or a line. Okay? And then an outlier is a data point that is very different from the rest of the data. So I want you to take a look at this example right here. So we've got basketball, shots attempted, and shots made. Okay, so our y-axis is shots made, shots attempted is our x. So we've got these two clusters right here that we can say that we have. So we've got our cluster 1, and then we've got cluster 2. And then this little guy up here would be considered our outlier. And there's a mathematical way to determine that. We can talk about that at a later date. But this would be considered an outlier for this data because it's not within group 1 or group 2. Okay. So a couple more things that we're going to add to this. Quantitative versus qualitative data. And causation versus correlation. So you have two kinds of data types of data that you can have. You have quantitative, which is measurable, so it's numerical, you should have numbers. And if you have qualitative, it's categorical, so you're talking about like colors, you're talking about maybe gender or ethnicities, things that you're putting into categories versus putting numbers to them. Okay, so correlation versus causation. Correlation, variables are related. So you're seeing a relationship built there. In causation, one variable causes the other to occur. So kind of like cause and effect. So moving forward, there's a few other things. We have correlation coefficient of R and residuals. Okay, so correlation coefficient, it is an R. Okay, so when we do this in the calculator, we're going to look for R. So correlation coefficient, it measures the direction and the strength of the trend line. Okay, so we have a few that we need to talk about. So if it's close to -1, if it's close to -1, then you've got a strong negative correlation. Okay, if it's close to 0, not strong or no relationship. And if it's close to 1, then you have a strong positive correlation. Okay, and this is something we're going to do in the calculator together. So then the last thing, we've got residuals. So residuals, a measure of how well aligned fits an individual point. So a couple things, we find the difference between the actual point and the point on the line, and then we look for no pattern. Okay, so we see how the points fit, we do some subtraction, and then we see if there's a pattern. So we're going to go back up top and we're going to do some practice with these vocab words, okay? So scroll back up top. All right, so we've got number 1. So the table shows the altitude of an airplane and the temperature outside the plane. So we have this table and it wants us to make a scatter plot of the data. Okay, so we need to take a look at our table. So normally this would be X, the altitude, and then the Y would be our temperature. When we put this in the calculator, we're going to make altitude our L1, and then we're going to make temperature our L2. So for right now, we're just going to make our graph real quick. So you can see for our X, we've got altitude. We need to go from 0 to 5,000, and it looks like it's broken up by 500. So let's see if we can do that. So 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. We can't do that. So I'm going to make that 1,000, and we're going to go up by the 500s that it says. So I'm labeling my x-axis right now. You should be doing the same. That's 5,000. And this would end at 6,000 for the data that we're representing. So then we need to look at our y-axis, which would just be temperature in degrees Fahrenheit. So we need to go from basically 0 to 60. So it's equal sides 0 to 6,000, so we can split this up into fives like we did on the other side, except we'll just do fives here instead of 500, and this should take us all the way up to 60. Okay, so you gotta look at the graph that you have or the graph you're given. If you're making your own, you can split it up how you want, but this is how we're gonna do it. And now we're just gonna plot our points. Okay, so we've got 0 and 59. We've got 500 and about 59.2, so they're about the same. 1,000 and 61, so it's a little bit above here, and it's okay. So 1,500, we've got 55.5. Again, we're doing this by hand, so it's not going to be exact. So I want you to continue to plot your points. Go ahead and do that now. All right, so this is what you should see for your scatter plot, something a little like this. Again, it's not going to be exact because, we're graphing by hand. So this is part A, we have our graph. And then, so for part B, what type of relationship does the scatter plot show? So if you're looking at your graph, you can kind of see that it's kind of this trend, even all the dots are kind of making this trend downward. So looking at it, we can say negative correlation, okay? And then we're going to use our calculator to prove that we're right. Okay, so with that negative correlation, we should always explain what that means. So for a negative correlation for this problem, as x, the altitude increases, I'm going to just abbreviate, it increases, y, the temperature decreases. Okay, so we're going to prove that we're correct with our correlation, our guess. So if you're ever graphing and you're unsure, we can use our calculator to determine if we're right or wrong. So if you have your calculator, we're going to go into our stat and edit, and we're going to plug in what we said list 1 and list 2 were into our calculator. So you're going to do, remember, altitude for list 1 and temperature for list 2. So go ahead and do that now. All right, so we should have all of our data in our list. Okay, so what we're going to do now is, first thing, I'm going to show you how to do a scatter plot in your calculator. So go ahead, go to y equals, make sure that your y equals is empty. So there should be no equation, so clear out anything that you need. So if you had like a 5x in here, you'd need to clear all that out. So go ahead and do that real quick. And then what you're going to do is you're going to hit second, and you're going to hit y equals where it says stat plot. So we're going to take the first one, we're going to hit enter, and we're going to make sure that on is highlighted. And then we have our dots for the scatter plot right here. Our dots for the scatter plot are highlighted, and we have X list is L1, Y list is L2. And then go ahead, we're going to go to our window, and I've already kind of played around with this, but normally your window is -10 to 10, you know, something like that. So what we're going to do is we're going to change our window around to show our scatter plot. So X, if you recall, is altitude. So my altitude, I'm going to make my maximum 6,000 instead of 5,000, because I want to see all of my data. And then we did an X scale of 500. So make sure you put your X scale as 500. And then our Y, if you remember, was temperature. So we're going to take our temperature. I'm going to do 65 so I can see all of my data points, because if you remember, we have that one that's 61.3. And then we also did a 5 scale here. So make sure you have that. And once you have all that set in your window, go ahead and hit graph. And then your scatter plot should show up. Okay, so our graph should look something like this. This is what we have on our paper. So if you want to compare, this is what we have right here. Okay, they look very similar. So if you want to turn off the stat plot because you're graphing lines in the y equals, you're going to hit second, y equals, and you're just going to go back in and you're going to highlight off and hit enter, and that will remove your stat plot. Okay, so now what we're going to do is we're going to take our data that we entered. Okay, so we have this data, and we're going to find our equation for our line, and this will tell us if we're correct with the information we have. So if you recall, we've got part C, it says find the equation for the trend line. So whenever you see trend line, this always means line of best fit. Okay, so whenever you see that, that's line of best fit. And then part D, what is the correlation coefficient R to the nearest thousandth? So we're going to do kind of a bunch of this at once. So I want you to hit stat, I want you to go to calculate, and we're not going to hit enter on one variable stats, we're actually going to go down to 4. This is called linear regression, so lin reg, and we want it to look like the ax plus b, the slope-intercept form. We're going to hit enter, make sure that our X list says L1, our Y list says L2, and then go down to calculate, and then we should have, mine didn't do it. Okay, so this is what we should have. If your calculator did the same thing, I want you to listen very closely. If you don't have R squared or R here, we're going to go to second catalog, okay? I want you to hit the alpha button, and I want you to find the letter D, which is just the X-1 button. Okay, so alpha D. And then I want you to scroll down until you see diagnostic off. Okay, so right now, if you didn't get the R's that we were looking at, you need to go to diagnostic on and hit on. Okay, so hit enter, and it should say done. So then we're going to go back through and do our calculating again. So option 4, and this should give us the R's that we want. Okay, so if you did not get the R's, you need to go through those steps. It happens, sometimes they're set to diagnostic off. In order for us to get the linear regression, we have to have the diagnostic feature on. So for our calculator, for our equation, for our trend line, we've got A and B. So A is just really your slope. So here we can say that negative 0.0122x plus 66, and we'll go to the thousandths place. So 0.282, that's the equation of our line. Okay, so now part D, what is the correlation coefficient to the nearest thousandth, and what does it mean? So our correlation coefficient is R. So R is going to equal to the nearest thousandth negative 0.9 tenths, hundredths, thousandths is 2. Okay. So now what does this correlation coefficient mean? So if you recall from the beginning of the notes, the closer that R gets to -1, that's a strong negative correlation, and that's what we have. So this is close to -1, so we have a strong negative relationship here, correlation or relationship. Okay. All right, so part E, what is the approximate temperature at 2200 meters? So instead of trying to plot that on our graph, we can just take this, this X value, because it's asking for the temperature, which is the Y value, and plug it in to our equation. So negative 0.0122, 2200, and then we're going to add this 66.282. So if we do that math and we add it all together, we should get approximately 39.442 degrees, and this is Fahrenheit. Okay, so that's how you would do a problem like this. So let's take a look at number 2. Make a scatter plot. This is all the same stuff. So I want you to do number 2 completely on your own. So go ahead and do that now. Alright, so this is what you should have had. So hopefully when you went through your questions and your answers, this is the information that you could tell me. Okay, so just take a minute, pause it if you need to check it. So you needed to do parts A through F. Okay, so E you had to find Y, and F you had to find X. Okay, so let's take a look at number 3. Okay, 4 different types of regression were used on the data set. Which of the following 4 residual plots shows the model that is the most appropriate to use? Alright, so if you remember from the beginning of the notes, we have residual. You would take some points, you would subtract them, and then try to find a pattern, or try to find no pattern. So we're trying to look for, since we're not going to do the coordinates here, we're going to look for the data set that doesn't show a pattern. So here for number 1, we have this pattern. It's kind of going up in an exponential way. Option 2 is going down in a linear way. So this is, a positive pattern. We've got a negative pattern. 3, it doesn't look like there's anything going on here. So 3 might be what we need to look at, but we should check out 4. 4 looks like we've got this pattern that could go back up, and do that kind of wave motion based off what we have. But 3 doesn't look like there's anything going on. So 3 would be the no pattern option, and that's what we want for the residuals. You want to look for no pattern. Okay. All right, so number 4, economists create a linear regression equation to predict the price of a gallon of gas, Y, based on the price of a barrel of oil, X. So the equation is given. One of the data points they used is there. So what is the residual for this data point? All right, so if you recall, residuals has this definition. I'm not going to scroll up and down. I'm just going to flip. So residual is a measure of how well a line fits an individual point. We're going to find the difference between an actual point and a point on the line. So we're going to look for that no pattern. So what we need to do here is this is the exact point, and we're going to use 60, our x value here, to find the actual point. So we're going to plug it in. So y equals 0.035x, which is going to be 60, and add the 0.95 to it. So when we do that math and we add it all together, we should get 305. So remember, y here is the price of a gallon of gas. So we're going to put the $sign here. So this is the actual price. Oh, sorry. This is the point on your line. So remember, the whole point is to figure out for a residual how well the line fits. So we're going to take the $3.62 and we're going to subtract the $3.05, and we should get 57 cents here. So it's pretty close. It's not exact, obviously, but the line is pretty close. So whenever you're trying to find the residual, with a word problem like this, remember, residual, you are trying to find the measure of how well that line fits, okay? All right, so for number 5, okay, in the following situations, is there likely to be a correlation? If so, does the correlation reflect a causal relationship, and explain? So we've got part A and part B, number of loaves of bread and the amount of flour used. So is there a correlation or causal relationship? So for part A, the number of loaves of bread and the amount of flour used, does the number of loaves of bread depend on the amount of flour used? Okay, is there a relationship there? And you would say yes, there's a correlation. So now you're going to say, is that correlation causal? So is there sort of a cause and effect relationship happening here? So if I use less flour, will I get the same number of loaves of bread as if I used more flour? Okay, so what happens when we use less flour or more flour? Does that affect the outcome of how many loaves of bread you have? And that is yes, this is a causal relationship. If you use less, you're going to get less. If you use more, ideally, you should get more, depending on the size of bread that you're making. So I want you to try option B on your own, okay? And then if you have any questions, come to office hours. Have a good day.